So in this video, I'm going to show you how to make an infinite procedurally generated asteroid field. You got your spaceship, and any direction that you fly it in, you're going to find more asteroids in that direction. However, I'm going to take a little bit of a meandering path. I'm going to start off with my initial approach using Gridmap. I think it has some good information about Gridmap if you've never used it before. It was my first time using Gridmap. However, I did eventually abandon Gridmap because it didn't suit my needs. So the next part of the video, and I'll have chapters for all this stuff so you can skip around if you want to. The next section is sort of my plan. How am I going to do this without Gridmap? And I do think that laying out the concept will help you understand the code that comes later on. Then I have a weird glitch that I had to deal with, and then I'll show sort of my incremental progress building up to that final asteroid field. There's some really cool visuals in there that I do feel like could be useful for other effects that you or I might want to do. And then finally at the end of the video, I'm going to go line by line through my code that actually generates the asteroid field. Many of you may wish to skip to that point, but I do think you're going to miss a lot along the way, so I encourage you to watch the whole video. Anyway, that's my justification for my overlong and a little bit meandering video. Good luck, have fun, please enjoy, I hope you learned something. The original tutorial that I followed to create this scene here had me create two grid maps. And the reason we create two of them is because we want to have a certain size for each asteroid in one of them and a different size in the other one. And you can see some of the smaller asteroids here and some of the larger asteroids over here. Grid map is the 3D version of tile map. You can select one of your meshes and select the paintbrush tool, and you can basically just paint them into the world, which is really handy if you're creating like a building interior, some exterior environments. I don't know if it's really the right tool for an asteroid field where you just have scattered asteroids here and there and elsewhere. Also, there are going to be certain limitations. The asteroids are not going to move around on their own, and they are going to be aligned into these particular grid spaces. And I wanted to create a different level that had an infinite asteroid field. And I figured I needed to interact with the grid map through a script. So I went to the documentation and I started learning about grid map. And then I created a test scene where I'm going to just experiment with the functions that are available. I set up a very basic test scene. I've got a world environment, a directional light. I've got my player with the camera attached so I can move around in the world. And I've got a grid map that is an exact copy of the grid map from the previous scene, of one of the grid maps. I attach a script to it, and I'm going to practice interacting with some of the functions, like set cell item to create a mesh instance of one of these asteroids in the world. And I'm going to use these 3 for loops here to initially just create an asteroid cube. It spawns in a little close and on the corner there, but if we get a new angle on it, we can see that I have successfully created a cube of the index 0 asteroid. So in set cell item, when I have that 0 at the end, that's just saying the 0th or first of my meshes is the one I'm going to use. And I could just use, 1, 2, 3, 4, 5. I think I have 6 of them to get those other different asteroids to appear. So with that proof of concept done, I'm going to modify the code slightly. I'm going to add in some more for loops, and I'm going to use set cell item invalid cell item, which if there is a valid cell item in there, will unset it, will basically remove asteroids from my world, which I'm going to need to do if I want to not use up all my RAM. And again, success, this is what it looks like. I have cut a hole or a tunnel into my cube of asteroids. So once more, I've modified my script. Now I've got a process function, and every 45th frame, I'm going to call this spawn asteroid function. It's going to look at a position in space ahead of the player, and if there's not an asteroid in that grid cell, I'm going to create an asteroid there. So this is going to be my first attempt at spawning asteroids ahead of the player. To give a little insight into this, I'm using globaltransform.basis.z to be the direction the player is facing. There's a grid map function named local to map, which will convert a vector 3D, a vector 3 of floats, into a vector 3 of integers for one of the particular grid spaces. And then I can use get cell item to access what is in that grid space on the grid map, and it will give me an integer, -1 if there's nothing there, represented by the invalid cell item, and it'll give me the index of the mesh that I'm using if there is one there. So I just check, is there one there? And if not, I'm going to put the index 0 asteroid there. And here we have it. As I fly forward in space, the asteroids spawn ahead of me, and I can keep flying and they keep spawning until I run out of RAM probably, but we're not going to get to that point, thankfully. With a small adjustment to spawn asteroid, I added these 2 lines of code where I'm going to take that direction that the player is facing. I'm going to get a rotated copy of it, rotating it around the player's basis Y and basis X by a certain amount, the spread constant that I've created up here, up at the top, plus or minus 20 degrees. And we can change that later if we want. Let's take a look at how it looks. And yeah, this is basically what I want. And I think that if all I was concerned about was the player basically flying in a mostly straight direction and making it appear like there's new asteroids always appearing ahead of them, this would be good enough. I could add in maybe like a fade in effect so that the asteroids don't obviously just like flicker in out of nowhere. I could spawn in the asteroids further ahead, but I want a much more open world type game. And so I want my player to be able to fly in any direction. And whenever they turn like 90 degrees, they're going to see that there's no asteroids over there. So that's one issue I have with this method. Another is that if I want asteroids of different sizes, I don't know how to do it with Gridmap without having a different grid map for each size, really each scale of asteroid that I want. So at this point, I'm thinking I actually need to totally revamp my approach. So the plan is to have my own data structure. It's going to be a 3-dimensional array. Each grid location in the array is either going to have an asteroid in it or not randomly. And the 3D array is going to represent these grid cells, this cube of cubes that we're maintaining around the player. And when the player moves from one cube to another, we're going to get the furthest away layer, the layer behind it, this 2-dimensional layer, and we're going to move all those asteroids to a position ahead of the player. Now let's look at this in just one dimension for simplicity and think about this. Here is the player in this one-dimensional array, and some of these array cells have a reference to asteroids and some don't. We're also going to need indexes referencing what is the far left, what is the far right in our array. And when the player, again, transitions from one cell to the next, we're going to go to the other end, in this case the left, and we're going to grab any asteroids in that cell and relocate them to a position on the far side of the array. In front of the player, where the player is headed towards, there's going to be a new, and we can re-randomize it if we want, a new asteroid over there. Then we're going to need to also update the indexes. So the left cell in our array is now actually going to be this position right here. We're just going to advance it to the right. And if the player had been moving to the left, we'd have to move it to the left. The right index is going to be, well, it would be off the end of the array, so we actually circle it back around. So we're treating this array as a circular data structure. So hopefully we end up with a fairly efficient data structure. It's of limited size, it's not changing size, so we're not going to balloon out of control with our number of asteroids and eat up all of our RAM. But at the same time, we're going to be able to maintain this, eventually a cube, here it's just linear, but we're going to maintain this cube of random asteroids around the player. Hopefully it will be a good illusion that appears like an infinite asteroid field. So I got rid of the grid maps completely. I changed each asteroid to be its own scene. It's the mesh instance of the asteroid itself with a static body attached to that. And I just have 6 different asteroids, so I just had 6 different scenes. I created a node 3D that I called my asteroid field. I attached a script to it, and I wrote a script to scatter the asteroids out in space, but I randomized the position within the grid cell, I randomized the rotation, and I randomized which asteroid was chosen. And yeah, it kind of looks the way I wanted it to. But then I noticed this weird artifact. Do you see this sort of empty X running through the space? So this is unacceptable, but I'd made my code too complicated for me to figure out what the issue was. So I had to shrink it back to something a little bit more manageable and investigate it on the small scale. And I found the same problem with a much smaller cube of asteroids that follow the player around. You can see that it does not maintain its cube shape. There is something wrong about how I'm positioning these asteroids.
One eternity later.
I finally got it working. I finally got a 3x3 cube of asteroids to follow the player around. The player stays in the center. The cube maintains its cubeness. It works. And now I'm going to add back in all that complexity that I took out. And don't worry, I will go through the script in detail, I promise. I just also wanted to kind of share my programming journey here in all its messiness. Step one is to just crank up the number of asteroids, which I did, and it looks amazing. I almost want to just do something with this. This is what it looks like from the interior of a 51 by 51 cube of asteroids. Every single asteroid is the same orientation, size, and mesh instance. The loading time definitely takes a bit of a hit, going from instantaneous to 3 to 5 seconds. And my frame rate is not quite staying at 60, but it's pretty dang close. And we are talking about, quick calculation here, over 132,000 asteroids. Now you may have noticed that the mesh that's representing the bars on my cockpit are suddenly wiggling for some reason. I do not know why this is happening, and it will continue to happen. I would love it if somebody could give me some advice, if anybody has any clue. Alright, so I looked it up, as we should all do when we have a question or an issue, and I was able to find it relatively quickly. So this other Godot user was asking, why am I getting all this jitter when the camera moves? And the answer is in this response right here. Your object has a proportional scale times 10,000, and that's what creates the effect. I do wish more people had education training and could communicate their ideas in a clearer way. Proportional to what? What the hell is this? I don't know. They then talk about how basically it seems like it's a precision error. You just don't have enough precision for the sizes of meshes that you're dealing with. That's the short version, at least my understanding of what this person wrote here. So I am not going to fix my issue for this video. I believe the fix is to simply not scale up the meshes so massively, but just make meshes that are the appropriate size so that you don't need to scale them up. So this would be like a go into Blender and make the proper model that you want rather than changing the scale dramatically. Moving on from that, I am now using the density parameter, which is just a percentage of the grid cells that will actually contain asteroids. So I make it way lower than 100%. This, of course, greatly improves my frame rate. Now I've added back in randomness of the position of the asteroids within the grid cell, randomness of which asteroid mesh instance actually gets selected, and randomness of their rotation and scale. One thing you may notice if you pay attention to the empty space between the asteroids in the distance is that new asteroids are just like appearing out of nowhere, right? They're just being spawned in, and it's unfortunately a little bit noticeable. My trick for how to fix that is going to be to start the asteroids out small and then scale them up to their full size. Now, when that happens right at the start of the level, it of course looks really weird because everything just inflates like a balloon. But when a new asteroid appears in the distance, this makes it look much more organic, like the asteroid is just getting closer to us. All right, and this is basically what I wanted. Everything looks good other than that jiggling mesh instance of the cockpit. If you try this level, it's level 10 asteroids. If you download my whole project and click on it, you may notice a few things. Well, one weird thing is that if you try and fire your gun while accelerating at full speed, the bullets will just disappear. That's because you're actually going faster than your bullets. The bullets don't add the player's velocity to them when they spawn. They just have a fixed velocity. So you're actually outpacing your bullets is what's happening there. But yeah, this works. All the asteroids are collidable, and now we're going to get into the code. So here is my asteroid field script. It's attached to a node 3D, and it creates and manages the asteroid field. It's got a bunch of preloads to reference those asteroid scenes, and every time a new asteroid is created, it's going to randomly select from this array. I've got the radius of my grid. This is basically half the size of my grid minus 1. And then I also have a variable here so that I don't have to keep redoing that calculation where the width, which is also the height and the length of my cube of asteroids, is 2 times the radius plus 1. I wanted to make sure that there were an odd number of cells so that I could keep the player in the center, so there was a center to keep the player in. So a single grid size, so basically one of the subcubes of my massive cube of asteroids, in which there will be at most 1 asteroid, is 800 meters on a side, and I can change this and get a larger or smaller spread of asteroids as I wish. Density, what percentage of the grid cells within my cube are going to contain asteroids? The model for my asteroids is actually quite small, so I scale all of them up randomly between 50 and 1200. Asteroid array is an array of either a reference to an asteroid or a reference to null if there is no asteroid in that grid space. Position array is an array of the center position of each grid cell that may or may not currently contain an asteroid. I want to do this separately from the asteroid array because I want to randomize the asteroid position within each cell, but I also want to know where is that center. I have 2 center variables. This is where the player was most recently, the grid cell index, but I update this every frame. I update the player center every frame, and then I check to see is it still the same as the center, and if not, that means that my player has moved from a grid cell to a neighboring grid cell, and I should update some of the asteroids correspondingly to keep the player in the center of this asteroid field. I have a function called generate field. This used to be just the ready function, but I need to ensure that my global player reference is set before this function runs. So instead of having it be the ready function, I just called it generate field, and there's elsewhere. It's honestly in my level script where I just call the asteroid field's generate field to make sure it puts all the asteroids out there. So that's what this does. This creates the initial asteroids. Now, the first thing I want to do is I'm actually going to reposition the player. So this will reposition the player to be in the center of the asteroid field based on the asteroid field's radius plus a half so that they're in the center of the cell, not at the edge of the cell, multiplied by the grid size. So then I calculate the player center. Initially, it's going to be the same as the center. I'm going to set an initial seed for my random number generator. I just picked this number arbitrarily. Mainly, you want to make sure that you have a seed and a density setting such that there is no asteroid that is spawned right on top of the player initially, and this worked for me, and so I haven't changed it. Now I'm going to create the cube of asteroids around the player. So I have 3 for loops. For I, j, and k is what I name them, but it's really x, y, and z. Matrix is a 2-dimensional array. Row and row 2 are 1-dimensional arrays. And what I'm putting into each row is either a new asteroid from this create asteroid function, or the position that's at the center of that cell. Push those rows into the matrices, push those matrices into the 3-dimensional array, asteroid array, or position array. I've got some print statements that I've since commented out. These are just from testing, and I left them in. Finally, the function that randomly creates an asteroid, or not, it might not, in which case it might return null. So create asteroid takes a position where the center of that asteroid would appear, although it will randomize this position slightly, and whether the asteroid should grow in. So if a random number between 0 and 1 is greater than the density of asteroids that we want, then do nothing, return null. Otherwise, let's create an asteroid. I'm going to pick a random asteroid scene from the array of preloads. I'm going to instantiate it, add it as a child of the asteroid field, the node 3D. I'm going to set the initial position of that asteroid. I'm going to randomize the scale between my minimum and maximum. I'm going to randomize the rotation of my asteroid, and then I'm going to randomize the position within the grid cell where I want the asteroid. And this is going to use that scale value that I calculated up here. I may have done this slightly wrong, but I think it'll basically keep the asteroids within their grid cell and not overlapping with neighbors. I didn't notice any overlapping when I was flying around. Some get really close, which they're allowed to do, but they shouldn't actually be overlapping. And then finally, if the asteroid is supposed to grow from small to its full size, we'll call this swell in function, not my best named function, on the asteroid itself. Otherwise, we just set the asteroid scale right here. I'm going to briefly digress into the swell in. So here's my asteroid script. Every single asteroid scene has this script attached. There is a tween, there's a function swell in, and the target scale that we want to reach from our initial scale of 1. And I just create a tween, and I tween the scale property from its initial value to the target that I want over the course of 5 seconds. When an asteroid needs to remove itself from the world, this function will be called shrink out, which basically does the opposite. It shrinks the asteroid using a tween down to 111 scale. It waits for that tween to finish, and then it deletes the asteroid itself. All right, so back to the asteroid field script, scrolling on down. Process. So this is where we're updating things. And the main thing we want to check for here is, has the player moved from one grid cell to another? I recalculate player center as a vector 3 of integers by taking the player's position, dividing by grid size, and then using the floor function. This actually really screwed me up for a little while. I was initially just dividing by the grid size and not using floor, but the problem with that is values between 0 and 1 will integer division round to 0, but also values between 0 and -1 with integer division will go to 0. And so there's this wider space between -1 and 1 that all goes to 0, whereas between every other pair of adjacent integers, it's just distance 1, right? You're either at 2 or you're at 3. You're either at 3 or you're at 4. But for all the way from -1 to +1, you go to 0. And there was this weird gap in my space, and it was awful, and all I needed was the floor function, but there it is. So if the player is still in the same grid index as it was before, return, do nothing. Otherwise, figure out the difference. What changed? Was it X? Was it Y? Was it Z? This vector will capture that information. If the difference was in the X direction, update the X asteroids, and then update the center to be the player's center X. Otherwise, do it for Y. Otherwise, do it for Z. Now, why don't I just update all of these on the same frame? No particular reason. Well, a particular reason, just a minor point, is that I wanted to spread out the burden of updating a bunch of asteroids. So the fact that this is an if, else if, rather than just an if and another if and another if, will make it so that we won't update 3 different things on one frame. We'll at least spread it out across 3 frames. Not much spread, but I felt that that was easy enough to implement, so I did it. Otherwise, something has gone horribly wrong, throw an error. I have a little helper function called wrap index. It takes the index into the array, the 3-dimensional array, and just makes sure it's a valid index. It wraps it around as if it's a circular data structure. Now, circular is like some weird hypertorus or something in this case because it's a cube that the X, Y, and Z all wrap around the other side. So I don't know, some topologist can tell me what the name of that mathematical shape is. And then I have 3 functions, update X, and down below update Y and update Z, and they are all exactly the same except they deal with one of the 3 different dimensions, so I'm only really going to go through one of them. All this code is available on GitHub, and you can check it out for yourself. So update X has the X diff. What is the difference that we're looking at? Are we moving in the positive X direction or the negative X direction? So this should be just 1 or -1. I figure out what is the index of the slice of my cube that I want to update. So 2-dimensional part of my cube that I want to update, what is that index? I'm going to wrap index on the center X value minus the X difference times the radius of my cube. I'm getting an edge of my cube. All the asteroids in that edge slice, I need to move them onto the other side of the cube to keep the player centered, to keep up this illusion that the player is constantly surrounded by an asteroid field. So since we're updating X, I'm going to loop over Y and Z. I'm going to get all the asteroids in that slice to update over all the Y and Z values. I'm going to shrink them out, which remember this will use QFree in that function in the asteroid script, and delete them when it's done. And then I'm going to change the array reference to null. Now, regardless of whether or not there was an asteroid that needed deleted, now we are going to add in a new asteroid. So I'm going to update the position in the position array. This actually was the code that I really struggled with to get rid of that X artifact appearing in space. This is how I fixed it. Basically, what I had to do was, instead of changing the position based on the index, which is what I was doing before, I just said, you know what, I'm going to keep track of the position, and I'm just going to add from the center where the player is at currently the size of the cube. How far is it to the other side of the cube? And that worked. And it does make sense, right? It's just, okay, this is where my asteroid is at right now. I want to move them a cube width distance to the other side. This is one way to do that. I think there are actually a couple other calculations I could have made just as easily, but this one worked, and I can't tell you how much time I spent struggling with this. So there's that. And then I create the new asteroid, and I put it into my asteroid array, making sure, of course, to pass it this position that I just recalculated in the line of code right above it. And that's it. Update Y and update Z are exactly the same. They just do it with Y and Z instead of with X. And yeah, that's the end of it. The script didn't end up being too long, barely 200 lines of code here. And such a relief to get this working.